Okay, guys. So evaluating limits algebraically, most of the time is very, very easy. It's kind of what you did in that warm-up. You just plug the number in, and as long as that gives you a value, and everything's approaching it, all of that, nothing weird going on, that's the limit. Sometimes, though, you have issues like plugging it in will give you a 0 in the denominator. So then you have to try some other approaches. You might have to factor. You might have to do something with a conjugate. But that's what we're doing today, is where you algebraically find that limit. That's what all of those words are telling you. So we do have 2 limits that you guys just need to know. These are special trig limits. You can find them from the graph, but these are ones you need to just be familiar with. So the limit as x approaches 0 of sine of x over x. You guys see how plugging 0 in wouldn't work? Yeah, it's not going to give you an answer. This limit is actually 1. Again, if you look at the graph on your calculator, you would see that that's what it approaches. The second one there, the limit as x approaches 0 of 1 minus cosine of x over x. Again, plugging in 0 wouldn't work. This limit does equal 0. So those are 2 that you just need to know, okay? They come into play sometimes when we're simplifying other trig limits, so just be familiar with those. All right, so we're going to try to do some of these now. The first thing you should always do is plug it in. That's what direct substitution is. Plug it in. If you get an answer, great. You don't have to do other stuff. Like looking at number 1, does anybody want to try to factor that? No, I don't either. But you don't have to. You can just plug to it. Okay? So to find this limit, we're going to do 8 times 2 to the 5th minus 6 times 2 cubed plus 3 times 2 squared minus 4 times 2 plus 1 over 3 times 2 to the 4th minus 2 times 2 plus 7. All right, guys, without a calculator, try to do that for me. I know. 2 to the 5th, that's the biggest one you got there, though. You can handle that. Use your fingers if you need to.
So that's just 2 to 30 is 100 plus 16 is 196. 8 through 32. 8 plus 3. Where is it?
It's 240, so it's going to be bigger than that.
Oh, it's 240. Yeah, you're right. Sorry. Yeah. That's right. 86.
It's okay if you write stuff down, guys. You can do that.
So much resistance.
It's good for you to work that muscle every once in a while. Blush. Talk to each other? Did you get the same thing?
Yes, sir.
Your denominator's 51. You're on the right track, but you can simplify more.
6 and 8. Wow.
You guys know the shortcut for checking if it's divisible by 3, right? Yeah. So,
So I got 7.
what is this magic? You've been missing out. It's so helpful.
It's 8, so it's 28.
Alex, did you get 71 or something?
No,
Really?
Yes, they're both divisible by 3. You know how to? Do you know how to check? We're discovering that some people. Okay, guys, up here. I think a lot of you got to what, 213 over 51. That is divisible by 3. Guys, the quick way to check to see if it's divisible by 3, add your digits. 2 plus 1 plus 3 is 6. 6 is divisible by 3, so 213 is divisible by 3.
Oh, wow.
5 plus 1 is 6. That's divisible by 3, so that, yeah, that's a handy shortcut that some of you, it's so sad you've been missing out. So it is 71 over 17. Woo, okay.
We got numbers that big on the test.
Probably not. All right. Whew. You're awake now. All right, guys, the second. What? Yeah, let's look at that. We've got issues on this one. What if I plug 3 in right away? Yeah, you end up with 0 over 0, okay? That is an oh no. We cannot do that, okay? So, yeah, you're just going to factor and see if you can reduce this at all. So, this is really the limit. We've got x minus 3 times x plus 2 over x minus 3. Oh, and that was as x approaches. We've got a hole. That's fine. We can still have a limit when there's a hole, right? Think graphically. Didn't you just like walk your little guys right next to the hole? Same thing here. So what do I get when I plug 3 into what's left? There you go. It's that easy.
Wow.
All right, number 3. Can I plug the 1 in? No. Do you remember how to factor difference of cubes? Okay, try it. Sorry, making sad noises. I'll write it up here. Okay.
You never taught me how to do it, so I had to learn from someone else.
Some of you will like yell, oh, that's soap, but then you don't know what soap means, so.
What's B1?
What do you mean, what's B?
B1?
Yeah, it's the cubed root of whatever that number is, so in your case it's 1.
Yeah. Don't the plus signs have to alternate, like if one positive and the next one is negative?
So that's going to be the same as whatever you started with. Opposite. Always positive. That's where the soap comes from. S-O-A-P. So if it started with addition, that'd be A plus B for the same side. A squared minus AB for opposite, and then always positive plus B squared. Okay. Were you guys good? Sorry. Okay. Okay, so let's factor that one. So your numerator is x cubed minus 1. So if you're thinking through that, what is A and B? A is just x. What is B going to equal? 1. Yeah, it's the cubed root of each of those terms. That's what the A and the B are. So you're going to have x minus 1. And what's the other parenthesis going to be? Good. Okay, so cancel out your x minus 1s. Can you plug 1 into what's left? And what do we get? 3. Good job. Okay. Not bad, now that you know how to factor by cubes, right? Some are difference of cubes. Okay. Number 4. And I plug the 4 in. No. All right. When you see a square root, what do you think you might need to do? Conjugate. Yes. Now there's a trick to this, though. Let me show you. I want you to make it easier on yourself. We're going to multiply numerator and denominator by this root x plus 2. Okay, the conjugate of that thing that has the radical. All right, on your numerator, don't actually multiply this all out. Leave it as x minus 4 times root x plus 2. It will make your life much easier. So don't multiply that. Only multiply the ones that are the conjugates of each other. What am I going to be left with in the denominator? X minus 4. Yeah, square root of x times square root of x is x. Then you've got those, the 2 in the middle, the conjugate part, they cancel out. And then negative 2 times 2 is minus 4. What do you see? Yes. If you didn't leave it factored, you're going to have a hard time seeing that. Okay, so don't multiply those out. Get rid of that. Plug it in. What do we get? 4, yeah. Square root of 4 is 2 plus 2. Okay, so every time, guys, when you do the conjugate, don't multiply the 2 that are not conjugates. Only multiply the conjugate part, leave the other part factored. So let's look at number 5, another one of these square root ones. Again, I can't plug 0 in. I know this square root is not in the denominator, but you're still going to want to use the conjugate. Okay, but with this one, what is the conjugate? Everybody always is a little confused on this. Yes, square root of x plus 1 plus 1. Okay, should I multiply the numerators? Yes, those are the 2 that are the conjugates. Should I multiply the denominator? No, leave that factored. What do I get in the numerator? What's square root of x plus 1 times square root of x plus 1? X plus 1. And what's the last part going to be? Minus 1. So what is that numerator really? Can we just go to x? Are you guys okay? Okay. Yeah, you see it? Okay. And then I'm leaving this factored because what happens? The what? They factor, it's factored, but okay, cross those guys out. So what does that mean for my numerator? It's 1, right? The numerator doesn't just disappear. Sometimes when people cross out the numerator, they're like, oh, it's not a fraction anymore. No, 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 it's still a fraction. That part is still in the denominator. So make sure you put a 1 in there as a placeholder. And now when I plug 0 in, what do I get? 1/2. Do you see it? Okay. Questions so far? Okay. 6 obviously has trig functions in it. There's a good chance we're going to need one of these 2 special trig limits, okay? So let me go ahead and walk you through this one. One thing with notation, you'll notice I keep writing the limit statement every time. You need to get in the habit of doing that. That can't like disappear until you're actually evaluating the limit. So I'm going to rewrite limit as x approaches 0. How could I rewrite tangent? What is that? Good, you remember. And then instead of divided by x, are you guys okay with me saying times 1 over x? Does that make sense? Okay. So it's the limit of all of that. Okay, I'm going to rewrite it again. So limit as x approaches 0. Do you agree that that step is the same as sine of x over x times 1 over cosine of x? Do you see it? Think with numbers. What if I had 3 over 2 times 1 over 5? Is that the same as 3 over 5 times 1 over 2? Yes, that's all I've done. I've switched the two denominators. It's multiplication, so that's okay. All right, what you can do now is actually evaluate these separately. So I'm going to do the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. So we're going to evaluate those two pieces on their own, and then we can multiply them together. So what is the limit as x approaches 0, sine of x over x? 1 times, how do I evaluate that limit? Plug in 0. What's the cosine of 0? 1, so what's that limit? Okay, so I've got 1 times 1. So that whole big thing just turns into 1.
How do these parentheses
Just say 1. Questions on that one? I know that one's a little tricky. Come on. So think, you're fine with tangent being sine over cosine, right? So let's pretend that I've got 5 over 3 and then divided by 2. Okay? Same, right? Yeah. It just is so much easier to see with numbers. Yeah, I'll explain what all of those weird things are. The multiple choice. We'll get to it in a second. Okay, let's turn the page. Last page of notes.
Whoa. Oh. Excuse me, that's very large.
All right, guys, we're doing the limit as x approaches 3 of f of x, and then I give you this f of x function. What you're really doing is evaluating from the left and the right. What do we know has to be true if the limit's going to exist here? Yeah, when I plug it in from the left or the right, it's got to be the same. That means when I plug it in here and here, I have to get the same answer. So you're technically doing from the right and the left, but you can just plug it in and see. I'll write it properly, but I think you can figure out the answer. I'll do from the right first. So that would just be the x squared part, right? So what do I get when I plug 3 into that? 9. And then if I do the limit as x approaches 3 from the left, that'd be the 6x minus 4 part. So what's your answer? Does not exist. Different values, does not exist. Left and the right were not the same. Okay, number 8 is kind of interesting. So if we look, I want to have you do both of these. We can do these. All right, what you're going to do is evaluate the f and the g separately. If they both exist, then you can add them together. Okay? So let's do the limit as x approaches 2 for f of x. So that's the first graph there. If we're evaluating limits, does that dot matter at all? No, it is there to mess with you. Ignore that guy. So what is the limit there? 1, okay. Keep forgetting to write things. Yeah. So partially it's me just making sure you see like what we're doing, that we're evaluating these two parts. If it's multiple choice, like these down here, doesn't matter. If it's free response, I'd like to see some sort of limit notation showing me what's going on. All right, guys, then g of x is the other graph. What do you think the limit is as x approaches 2 there? 3. So I'll go down here. What is the limit as x approaches 2 of f plus g of x?
4.
There you go.
Oh.
It looks really complicated, and it's just not. All right, let's look at 9. We've got another piecewise function here. All I'm asking you is, does it exist? What do you think? So it's not continuous, you are correct. But does the limit exist? So 3 bullet points, you'd be right. First one doesn't work, we don't have to do it. But what about the limit? Do you get the same thing when you plug 4 in for each piece? Yeah, then yes, the limit exists. So I probably should have asked you what it is. If I asked you that, what is the limit as x approaches 4 for this function? Good. Your left and your right hand limit both equal 0, so that's why that equals 0.
So the square root can't equal 0.
The square root can. The square root of 0 is 0. You just can't take square roots of negative numbers without getting exceptions. There is no such thing. Do what? I'm sorry. No, because this isn't the continuity test. Yep. If it was, yes, you'd absolutely do your bullet points. But this is just, does the limit exist? All right. We've got a few multiple choice questions left. Now, guys, the weird numbering on the side, that's just telling you this is from the 1993 AB Calc exam.
That's a while ago.
It is a while ago, yes. AB Calc's been around for a while. All right, so let's look at this one. So you've got what f of x is equal to, and then they're asking you the limit as x approaches 0 of f of x minus f of 0 all over x squared. Okay, you see the issue with just plugging 0 in right away, right? Okay, I know it's multiple choice. I'm still going to write the right notation just because. So what is f of x? Okay, so instead of this f of x, I'm going to write 2x squared plus 1 minus, what is f of 0? Meaning if you plug 0 into the f of x function, what do you get?
1.
1, okay. Over x squared. Let's simplify that. So what's left in my numerator? Okay, over x squared, so what can I do? So what is the limit? 2. Okay. Good job, guys. You answered an AB Calc question. So that's from the 1993 AB Calc exam. So the next one is from the 1997 AB Calc exam. We'll look at this one. Let me just explain this one, guys. So your denominator here, if you were to plug the 1 in, you'd have natural log of 1. What is that? 0. And there's no way to go about simplifying this nicely. So the answer to 11 is just non-existent. Okay, because do you guys remember that? Natural log of 1 is 0. E to what power is 1? Vaguely remember logs. Oh, yeah, those are a thing that come back. That's probably the hardest part of calculus for you guys usually is where you're doing the derivatives and integrals and everything for logs and natural logs. Okay.
Natural log of 1 is always 0.
Mm-hmm.
What about log 1? Is that also the same thing?
Yeah, 0.
All right. Okay, 12. Now for this one, it's saying as x approaches 2. Do you guys see how the 2 is in both pieces? Like that's where we would switch over from one piece to the other. So you do need to plug the 2 into both. Now, you don't know exactly what natural log of 2 is equal to. But do you know that natural log of 2 and 2 squared times natural log of 2, like, do you know whether or not those are the same value? Okay, are they the same value? No. So what would you tell me about this limit? Yeah, non-existent, that's the same as does not exist. All right, guys, one more. Whoa, too far. Don't worry about that part. All right, this one, it says if a does not equal 0, then the limit as x approaches a of x squared minus a squared over x to the 4th minus a to the 4th is which of these things? Okay, looks complicated to begin with. Always try to simplify if you can. So let's think about factoring. I'm not even going to factor the numerator yet. Let's look at the denominator. What does that factor into? Very good. That is difference of squares. X squared minus a squared times x squared plus a squared. Then what happens? Then it gets a whole lot simpler, right? Okay, can you plug the a in now? What do I plug it in for, just to make sure we're all the same thing? Yes, you plug it in for the x. So this is going to be 1 over a squared plus a squared, which is? Yay! So your answer is B. Okay? Not too bad? Pretty bad? What? A. Because it was as x approaches a.
Oh.
So no numbers here. That's what makes it look scary. I did what? Sorry. Oh, sure. Does that one make sense to you? Yeah? Okay. Any questions, guys? Because that's the end of our notes. Okay, what we're going to do next is not the classwork worksheet that's attached to that for you. We're going to do a quizzes, and I want you to have a partner. If you want to do it on your own, that's fine. Yeah. All right, guys, so hop on in.